Assalamualaikum and very good afternoon. Alhamdulillah. Allahumma salli ala Sayyidina Muhammadin wa ala alihi wa sahbihi wa barik wa sallim. In previous video, we have learned on how to evaluate the limit by using the analytical method. So in this video, we are going to learn on how to evaluate the limit at an infinity. We are interested in examining the limiting behavior of function as x increases without bound, where x approaches infinity, or as x decreases without bound, which means that x approaches minus infinity. So let's look at these two formulas. We have limit k, so where k is a constant, any number, okay, as x approaches infinity, so will be equals to k. Okay, next, if limit for the function 1 over x to the power of n as x approaches infinity will be equals to 0. So this is because when 1 divided by, okay, x to the power of n, so x approaches infinity, if we substitute infinity right here, 1 divided by very big or very huge number, so it will approaching 0. Okay, for example, we have limit 5 plus 1 over x as x approaches infinity. So in this example, we separate, okay, by sum and difference rule. Okay, so we have limit 5 plus limit 1 over x. So limit 5, where 5 is a constant, so follow this formula. We got 5, okay, and then plus limit 1 over x. So 1 over x will be equals to 0. So 5 plus 0, we get 5. So in order to evaluate the limit, especially on rational function, firstly we divide the numerator and denominator by the largest power of the variable that appear in the denominator. Okay, so for example, evaluate limit 12t square minus 15t plus 12 divide t square plus 1. So as we can see, the highest power in denominator is 2. So we will divide each term in the numerator, okay, and the denominator with t square. Okay, so dividing 12t square with t square, we got 12. Okay, and then we have 15 over t, and as follows. Next, we evaluate the limit. Okay, we evaluate the limit. So according to the sum and difference rule, okay, limit for 12 minus 15 over t can be separate, okay, as this step. Evaluate the limit, limit 12 constant, we got 12, okay, limit 15 over t, so 15 over t following this formula, okay, following this formula will be equals to 0, okay, because 15 over a very huge number, infinity, so it's approaching 0. Okay, next 12 over t square, also 0. In denominator, limit for constant 1 equals to 1, and lastly limit for 1 over t square, so 1 over infinity, and then 0. Okay, then we can simplify as 12 over 1, which is equals to 12. Alright, so next example, evaluate the following limit. Limit x squared plus x minus 6 over x minus 2 as x approaches infinity. Okay, so our highest order in denominator is 1, so we divide any term, okay, in denominator and the numerator with x to the power of 1. So we get something like this. Okay, so evaluate the limit, substitute infinity, So you will get infinity plus, okay, so, this is a constant, plus 1 minus, okay, 6 over x, which is 6 over infinity. It will be 0, and then 1 minus 0. Okay, so as a conclusion, we get infinity. Okay, so B, we have limit square root of t minus 3 and then divide t minus 1. So highest order is 1. Okay, so we divide with t to the power of 1. Okay, so as we divide this equation with t to the power of 1, we will get this equation. Okay, so 1 over infinity, we will get 0 minus 3 over infinity, okay, also 0, and then 1 minus 0. So we will have 0 over 1, which is equals to 0. C, okay, we have limit 2x cubed minus 2 divide x cubed plus 1. So the maximum, sorry, the highest power of in denominator is 3. Okay, so we must divide with x to the power of 3. So as we divide with x to the power of 3, we get this equation. Okay, so evaluate the value. So 2 minus 2 over, okay, 0, and then divide 1 plus 0. Then we will have 2 over 1 equals to 2. Okay, so we have learned on how to evaluate the limit at infinity. So next video, we'll briefly discuss about the concept of continuity. So thank you very much for your interest. Assalamualaikum and very good afternoon.